SaltConf. How many of you attended the trainings that we've had the previous 2 days? Okay, a few of you. Did you happen to attend the getting started? How many of those that attended the getting started with Salt? One person, 2 people. Okay, a little bit more. All right. Well, what I'm glad is that you didn't all raise your hand because there is some overlap. This is more of a tech talk lecture than the hands-on perspective, and I go into a little more detail on some components than I did the previous 2 days. So welcome to SaltConf. My name is Mark Hopper. I am a solutions consultant for SaltStack. What that means is from a pre-sales perspective, I'm paired up, I'm part of the account team. I do demos, I do technical discussions, proof of concepts, I help fill out RFPs. I love RFPs, by the way. Yeah, if you've ever dealt with an RFP on your end, you probably feel that it's probably just not as fun on our end as well. But that's kind of what I do. I handle the technical side of the sales perspective. I've been with Salt for about 3 years. It'll be, I believe it's 3 years next week. And in Salt land, that's a long time. But it's been a great journey. How many of you, is this your first SaltConf? Awesome, I love that. That's fantastic. And I would expect that in this room. I did see an older version of this t-shirt walk in, which indicates that you probably been to SaltConf before. Or did you? I used to work with Tom. Okay, so you're a friend of Tom. This is the, there's a slight variation between, this shirt was given out last year. And for a plug for the party, you can choose this shirt. This is an awesome shirt. If you think it's Star Wars, you're mistaken. And I was just, I've owned last year's shirt. It's kind of not as bright. It's the exact same graphic, but it's not as bright. But just yesterday, I was noticing stuff that I haven't even noticed on this. This shirt goes as deep as you want. And if you're a fan of if you're a child of the 80s, this shirt is magical. So you can get one tonight, just a plug for the party. The other thing that's always interesting to me about SaltConf, besides if this is your first one, is who thinks they came the farthest to get to Salt Lake City. So if you think you came the farthest, raise your hand and tell me how far you came from. Germany, that's pretty far.
5 blocks.
5 blocks? All right, church and state over there, is that a?
UK.
The UK, Germany's a little bit farther than the UK. Anybody else? All right, we got Germany as a winner here. The other day I had someone from Singapore, and I'm not sure you can get, except for maybe Antarctica, I'm not sure you can get farther from Singapore because it's pretty much on the opposite end of the planet. Just reading the other day that United has a nonstop from LA to Singapore. It's an 18-hour flight. I've flown from Atlanta to Dubai. I think that was close, but anyway. Welcome. I welcome whether you're 5 blocks away or several thousand miles away from Germany. Welcome to SaltConf. Let me kind of explain a little bit of what this session is. In my first SaltConf, I was brand new to Salt. Well, it was about 6 months I'd been with Salt, and it was my first foray into open source. I had come from a systems management background. I spent 8 years at Symantec with their Altera/Symantec with their systems management. Prior to that, was with EMC, mainly as one of their post-sales implementation consultants dealing with mainly high availability clusters, where we were clustering applications in various data centers, operating systems from a data center background. But it was always proprietary. It was never open source. So they kind of tasked me with getting started with Salt, mainly I think because they said this poor guy doesn't understand open source and doesn't understand our product. And it was actually a success. And so I've kind of been pigeonholed into doing this session, which I enjoy. I actually give this presentation several times a week. And what this has, from SaltConf17 until now, this has been an evolution of conversations that I've had with you guys, with people just like yourselves, explaining what salt is and how salt, some of the components of salt, and getting down a little bit technical of how salt communicates. Because I found that what was out there, we could expand the knowledge base of how we see salt at SaltStack. So I always like to start this with what is salt. So I'm going to ask you guys, and I don't want you, what I would like you to do is, I would like you to answer, if you feel so inclined, what does salt mean to you when you coming here? We talked a lot about it in the open keynote. We used some buzzwords, and I'll use those same buzzwords today. But I want to know what you guys, obviously you're here for a reason. You've been tasked with using salt. You're probably fairly new to salt. What are some of the things when you think of salt as a product? What do you think of? So, I heard an answer over here. No, go ahead.
Time savings.
Time savings. So salt is to save time. Automation. Okay. Orchestration. What? Configuration management. Persistent. Okay. All of these answers are correct. And I'll be honest, the vast majority of people that I talk to on the phone, they're looking for orchestration and configuration management. And they always lump us with 3 other products. Can you guys tell me what those are? Puppet, Chef, and then Ansible. He's got Ansible staring me in the face over here. Yeah, Puppet, Chef, and Ansible, absolutely. And so we are always lumped in, and that makes sense to me. I use this analogy that there's this playground, and the older kids on the playground were Puppet and Chef. And then Ansible and Salt, kind of the younger kids on the playground. We were able to play with those older kids and learn from the things, when they fell and scraped their knee because they tripped over the asphalt, not realizing there was a step there. We were able to learn from that and not trip and scrape our knee. However, that's not what we at Salt view salt. If you ask any of us what salt is, we're not going to tell you we're a configuration management play. Now, we do that, and we're biased, and we think we do it as good or better than the other players in the market, but that's not how we view ourselves. What we view ourselves is a real-time automation platform. And if there's anything you take away from this entire conference, and hopefully you get a little glimpse of that from my talk today, is that we are way more than configuration management. We want you to use our configuration management pieces, but we're way bigger than that. And we just saw an example with Bloomberg. Bloomberg stood up there, and what did they say they use for configuration management? Chef. And you'd think we'd all cringe as salt people, but to us, that's fine. We'll orchestrate. We'll automate Chef. That's not a problem. We'll automate Puppet. No big deal. So that's the one thing of what we are. So I want to spend a few minutes to talk about what makes up a real-time automation platform and how that relates to Salt. So the first thing, when we start talking about automation platform, I think one of the most key important pieces of that is you need some kind of logic engine. You need to be able to determine what decisions to make automatically. So if I'm hiking down this spooky path, I need to know, do I go left and go with the guy with the axe that's waiting for me? Or do I go right and that guy has a chainsaw, right? I got to make some decision somewhere. So in an automation platform, if you're looking for automation solutions, it needs to have the ability to make decisions intelligently, and so you need to have some kind of logic engine. The other piece to an automation platform, and I think this is where we're known for, like I said, we get lumped in with Puppet, Chef, and Ansible, but you need to be able to do configuration management, and you need to be able to orchestrate. And those are, you need to be able to take the puzzle pieces out there, not only from a single instance perspective, but across the entire infrastructure to orchestrate that. And then once you put all those pieces together, that's vitally important to this automation platform. And so you need to have a configuration orchestration management piece of the puzzle, as you would say. And then I think this is crucial, and this is really, and we'll get a little more specific in what do I mean by that, but this is crucially one of the biggest differentiators between us and other players, is if you're going to truly automate something in your environment, and in the speed in which environments are happening today, you need to have some kind of event bus or high-speed message or communication. When Tom Hatch created Salt, he needed to create a remote execution engine. That was the need he wanted. And so he looked at the technologies out there. He had used Puppet, and while Puppet does a really good job of configuration management, from a remote execution perspective, it was a little challenging. And so he decided to leverage technologies that the financial industry was using. So a high-speed event bus. You need a high-speed communication. So if I'm making trades, and let's just look at the stock market. We just had Bloomberg up there, right? And they had their fancy, I love that dual display thing that they had up there. That's pretty cool. But if you're making trades, you want to buy low and you want to sell high, right? That's the deal in the market. So when I go and I call my broker, or I log on to E-Trade or whatever platform I'm doing to sell, or move my retirement around, I want that to be fast. As soon as if I see the stock hit a certain level, I want to be fast. I don't want to wait till that drops back down. And with my luck, I always wait and it drops back down. But we want that to be fast. And so on the trading floors, the systems that deal with that, and Bloomberg's definitely an example, they're using these high-speed communication, so it's in as real time as possible. And that's key to an automation engine. If you're going to automate something based on an event that's happening in the environment, you need to have that happen quickly and in real time. And so that's another piece to the puzzle. So as you're out there, some of you may have come to SaltConf because you're evaluating Salt, or you have other players in the piece. If you're looking at an automation platform, you need to have those three things. So that's kind of what goes from there. Now, what I want to do now is I kind of want to take a step back, and I want to talk about Salt from kind of the ground up. So as someone asked me, I believe it was this gentleman here, asked me, he installed some Salt, and that's really all he's done. Is this the right class? And absolutely. And what I want to talk is take a step back and talk about what is Salt. What is Salt to me, based on my experience in talking with people like you? What is Salt to me based on what we're trying to accomplish as a company? We heard Mark Chen, our CTO, talk a little bit about our journey, and Alex Pei, our VP of product. We heard these guys talk, but I want to take that down to what is Salt from a component perspective. How does that relate to what Salt does, and how does that relate to our vision? So that's kind of what I'm going to go through here. Before I start into this gets pretty granular, I'm not going to lie. But before I start that, based on what you heard in the keynotes, based on anything I've just said right now, any questions? I want to make sure that we can answer your questions or anything, or use cases. All right. Okay. There's a little time check. So Salt, I'm pretty old school. I remember this operating system, probably the most stable operating system on the planet. It was called DOS 3.5. I don't know if it was more stable than my first computer, which was a Commodore VIC-20 that had a tape cassette thing. But I'm pretty old school. I use some old school terminologies. So I apologize for that, but my age just happens to be there. We're a client-server technology. We have a server, which is the Salt Master. We have an agent that runs out there in the data center or from that perspective. And we'll talk about some other cool stuff that doesn't involve an agent. But at the end of the day, we're predominantly a client-server technology. So we have this agent. We call that a Minion. And so when you hear a Salt person talk about a Minion, the terminology pretty much means the agent running on a box or a box that's running on our agent. It's not, my favorite movie line. I'm not a big pop culture guy, but my favorite movie line comes from Independence Day, and they're on the airplane, and I think it's Jeff Goldblum. His character is talking to the president, and he's talking about Area 51 and aliens and stuff. I love that stuff. If it's not a spaceship or laser beams, I'm not really interested, and hence I love this shirt. But my favorite line is he's telling the president basically saying that this stuff doesn't exist. And his chief of staff or advisor, somebody says, Mr. President, that's not entirely accurate. That's my favorite movie line of all time. And so when we refer to a Minion, it typically means a node running the agent, but sometimes we'll refer to other devices that aren't running the agent as Minions as well, so it's not entirely accurate. But that's the overall thing. And we do have agents for Linux, Windows, in the open. And then from an enterprise perspective, we'll run on AIX and Solaris as well. There is an OS X Minion out there. I believe that's in the open as well. But basically, that's the agent. And so when I refer to Minion, that's kind of what I'm talking about. So the one thing that I really want to get across is the differentiating factor is this this message bus, this event bus. By default, we use something called 0MQ. We also support Tornado's TCP stack as an event system as well. But 0MQ is the predominantly. And really, that communication is the biggest thing that separates us from every other player. And so I'm going to talk a lot about that. And hopefully, by the end of this presentation, combined with the information I gave you before, you'll see the vision that I see, at least a little bit. Like I said, if Tom wanted to create this remote execution engine, he chose this 0MQ, this message bus as a way to communicate. And what happens is it's kind of I've heard it described as a sub-pub model, meaning the agent subscribes to the message bus, and then all the commands are published on that event bus from that perspective. And what happens is the Minion comes up, it sends over a public key over to the master and says, hey, I want to play on the playground. And the master says, you're cool, you can play on the playground. And so it accepts that, it sends over its public key at that point to the master, to the Minion, and now we have a persistent, we heard that earlier, as what Salt is, it's a persistent, always-on connection between the Minion and the master. And the communication is encrypted. And just to kind of give you technically what happens is the master makes a command. That command structure sends a command. It encrypts that command with its private key. The Minions decrypt that with the public key of the master. And if they respond, they encrypt their traffic with their private key. And the master decrypts it with the Minion's public key. So that's kind of how that goes. So we have this always-on encrypted communication channel between the master and the Minion. And that's really the foundation. That's the biggest differentiation between us and everybody else. And to me, it's actually puts us in a section of what we are above and beyond configuration management. So let's talk a little bit about the various components here and talk about the communication. What does that do? What does that mean? And then we'll talk about components, and this is why it's important to me from a getting started perspective, because these are components that I want you guys to use as you're getting started with Salt. And these are components that I have found over the years that I've given this presentation that people don't know about. I actually had one of our developers. We have Adobe has a big facility here in Utah. I'm based out of headquarters. And we do a meetup with Adobe, and I gave this presentation once at our Adobe meetup. And we had about 80 people in the room, including, because they're like literally 5 blocks away from us, we had our engineering group, pretty much all our engineers there. I'm pretty sure they were there for the free pizza and not to hear me speak, but a brand new, he'd been an engineer for like 6 months, so it was fairly new at the time. He came up to me and said, I had no idea we did that. So I like to give you this information. So let's talk a little bit about this communication. So we have this persistent always-on connection, and what Salt does is the Salt master has a command structure. And that command structure is basically, has 2 components. It has the target and then some instruction set. And that command goes across that message bus. All the minions that are participating in that get that message. And then, and so here is part of the, in my opinion, part of the genius of Salt, having worked with other systems management solutions in the past, is that the minion self-selects and determines if that command applies to them based on the targeting criteria. And if it doesn't, that minion says, yeah, that doesn't apply to me, and goes on. It's like me listening, sometimes this gets me into a lot of trouble, but me listening to my wife talking to the kids. If she's telling the kids something, I kind of just ignore that, because it's the kids that need to go take out the trash or the dishes. A fault of mine is sometimes I am not listening when the command comes to me, and I drop that command too, but it brings me a little bit of trouble, but that's just a personal fault of mine. But it's similar in that regards that it's only listening for it, self-selects, and then it just keeps going. There's none of this, oh, that's not me, okay, that's not you. There's none of this acknowledgement going back and forth, and so it makes it asynchronous and extremely fast. So, and so we can execute across thousands of nodes simultaneously from that perspective. Question in the back. Great question. What's the significance of backslash to the target? In this particular case, what I'm doing is I'm just exiting out so that it doesn't interpret, so it interprets this as kind of a globular expression. And so in this case, the star is everything. So in this command, this goes out to everybody. So everybody would execute that. I could put an explicit name there, host name or minion ID there. I'll talk a little bit about what else you can do, because even just being able to do, and I could wildcard a host name like star, web star, and anything with the name web in the name would execute, right? But that does limiting. I'm going to talk about how we can do some more advanced targeting here in a second. But great question. In the back. It's basically the application layer. It's using 0MQ that's in by default, or Tornado's TCP stack to communicate. So I mean, it's a process that runs that. And then the instruction set is made up of modules and functions. Functions are a subset of the modules. I like to think of the module function as a noun and a verb. So for example, the noun being package. I have a package, that's a thing, right? I can grab a hold of that. And then the function would be, what am I gonna do with that package? Well, I'm gonna install that package, or I'm gonna remove that package. So I like to, those are verbs, those are actions. What am I gonna do with it, right? So the instruction section is typically made up of a module and a function and an argument. Now, much like the Minion self-selects, the Minion also has the modules sitting on the box. I do want to just differentiate a little bit between Salt vernacular and, let's say, Puppet vernacular, if you're used to Puppet. Modules in Puppet are what we call formulas. They're just all the components that install an application, for example. When we talk about modules, they are actual bits of Python code. This is where the community is so important to us because we have hundreds and hundreds of modules that are written in Python that are part of our agent. They come down with the agent if you can sync them and add new ones, but that's really the core pieces of Salt are these modules. And they have anywhere between one function to 20, 30 functions within each module. But those are really the core, and the modules, again, reside on the Minion, and they do the lifting. So the command goes out, the Minion self-selects, and then it runs this module command that are sitting on the Minion, and the Minion does the heavy lifting. And so only the master is not actually executing that kind of code that happens on the Minion side. So, this is kind of the remote execution function of Salt. I'm going to go do something now. I'm going to go put a package that will fix Heartbleed, shell shock, or recently we've had the WannaCry virus, right? So you could use a command to go out and fix that vulnerability in real time across your entire enterprise. And that's remote execution. Well, really the same thing applies when you start going upstream and having more complex. So let's say I want to create a programmatic picture of what that machine is. And that machine is an Apache web server, and it has this website on there. I create this programmatic picture. We call that a state file. That's written in YAML, which is if you're not familiar with YAML, it's a very English readable. If we have time, I'll show you a YAML file. It's very English readable, and that's putting something in state. So that's kind of the next level. First level is you run a command from the console. It's real time. It's a remote execution. I want you to do something right now. The other one is I want to put you in state, and I need to list these different commands in order to happen in the right order. I create this programmatic picture. I'm going to apply it. I'm going to say this is what you're supposed to look like. That's a state file. That's kind of the next level. And then the third level is what we call an orchestration file. An orchestration file will say, node A, I want you to build yourself as a database server, and then when you're done, node B, I want you to build yourself as an application server, and when you're done, node C back there, you're our front-end load balancer, I want you to add node A to the application pool. So that's an orchestration, and so that's kind of a next level of complexity. But if I break it all down, it's a series of modules and functions. And that's how Salt works from that perspective. So that's kind of, I'm going to shift gears a little bit. Any questions on that? All right, so let me shift gears a little bit. A little time check. Yes.
What constructs the message and is it always broadcast?
So the command that's given is, that can either happen by someone, I don't know if this is answering the question, but typing from the command line, or maybe they're using SaltStack Enterprise and they're clicking something in our UI and it's telling, but ultimately it's going to issue a command that's going to do something out there. I don't know if, does that answer your question?
Is it always broadcast?
Yes. Everybody gets it, but great segue, I'll pay you after the class. I want to talk about an object called grains. Grains, and this is, you get a little bit of vernacular, and I found a secret yesterday. Some people in the company are kind of regretting using these. I love this pun stuff, but salt grains. Salt grains are a key value store where it's about attributes. It stores attributes. Those attributes, so I give you attributes of me. I'm a 6'4" guy with no hair. I weigh too much. I wear glasses. Those are some of my attributes. But grains are other attributes, like how much memory do you have? What's your operating system? Are you physical? Are you virtual? There's a whole series of grains that we collect. And you can add your own grains. You can make custom grains. So you can have a grain of role web server, role database server, location San Jose, location Amsterdam, or you can have rack 15, slot 7, right? You can create these custom grains and put attributes to that particular minion or instance. Now the cool thing, going back to this question back here, is it broadcast to everybody? Yes, it's broadcast to everybody, but I can target based on grain data. So I'm not targeting against hosts. I can target all my Apache servers, or I can target all my web servers from that perspective. The other piece that grains can be used on is to variabilize these state files. So if I have a state file that's configuring an application and that application needs to listen on an IP address, typically they'll go, I'll just put 0.0.0.0. It'll listen on all IP addresses. What if you don't want it to do that? What if you don't want it to listen on all IP addresses? What if you want to listen to on its one IP address, and if there's someone happens to put a different IP address, I don't want that app listening on it. Well, what you can do is in your configuration, you can reference listen grain IP of Ethernet 0. And then what happens is when it configures that app will pull its own IP address from its grain data and put it in there. And so you may have the same application, but yet the configurations are slightly different based on Minion-specific data. So grains are absolutely really important. So as you're getting into Salt, I use grains to target, use grains to configure from that perspective.
So is grain something you set up what you want your system to collect? Or do you have to manually go and put stuff?
It depends. So some grains collect dynamically, and you can create custom grains that dynamically to get data. There's a bunch of grains that come out of the box, right? And then something like role web server, you just assign that grain during the provisioning process and say, like when I spin up a new node, I have a profile that says this node is going to be an Apache, so it says role Apache, and I do that as part of my provisioning process. We have another data set, again, it's a key value store, it's called Pillar, and where grains are kind of like Minion data for the Minion to self-select on targeting, to configure. We have this object called Pillar, and Pillar is kind of where we like to store secrets like API keys or passwords, and only the master has access to that, and the master will dictate which minions can access that, have that data. So it's kind of like data for the master to control. And what you can do with Pillar is you can actually put configuration information in there, you can put secret information in there, but the master really controls who gets that data. So a minion will log in and say, hey, what's my Pillar? The master says, okay, this is your criteria. You get access to these sections of Pillar data. And so, for example, application group A may have a password for their MySQL databases be X, and application group B may have their passwords for MySQL be Y, and they can have the exact same configuration state file, but they're using the Pillar data to configure the passwords on that particular thing. That's one example. Or if I need an API key to communicate to AWS, I can store that in my Pillar and grab that API key, that kind of thing. There's one last data set that I want to talk about. It's called the mine, where if grain data is for the minion to use, Pillar is data for the master to divvy out. Mine is minion data for other minions to use. So let me give you an example of how this all flows together. I have a situation where I spin up a web server, and that web server will say it's role Apache and its IP address, and it'll store it in the salt mine. Someone else may need this information. The Pillar actually tells the minion what grain data to put in the salt mine. So it's getting that configuration from the Pillar to say, the Pillar says, oh, go put your mine data and this data in the mine. And then as part of the process, as part of that, I orchestrate when that web server comes up. As soon as it comes up and it's configured, I tell the load balancer, oh, go to the salt mine, grab everybody with the role of Apache, take their IP addresses, and add them into the application pool. And so it orchestrates, and so mine is minion data for other minions to access. And this is where, what database to talk to downstream, or what front end I needed to open up for upstream. So the mine allows you to use to take other Minion's data for configuration to talk upstream or downstream. Does that make sense to people? Any questions on that?
Is there any way to enforce a pillar set across the different environments? For example, I have environment A that has this set of pillars, and when environment B gets created, I need to verify and make sure that these pillars are available to that environment also. Does that make sense?
So you have a pillar that's available to A, but you want B.
Set of pillars. So I have environment A, environment B, right? In order for environment A to function correctly, all of these pillars need to be available. You know, the values may be different per environment. But one issue that we run into is we are spinning up a new environment. We copy the pillar set from environment A over to environment B, and then in the meantime, certain things may change in A that actually need to be applied to B. You know, and this through all the source. But is there a way to, hey, before you run a state, verify that all these pillars are available?
Yeah, so the question is, essentially I have a pillar for A, pillar for B, and B needs to match A, but sometimes B would be out of sync because A is newer or something. So what you would do is, you can do that, be orchestration, but it would be, you would probably, before you ran the state, step one is tell the master to ensure that these pillars are identical. And if they're not, kill the orchestration. Notify somebody that this needs to be updated. And then step two would be go run the state on B after you get a success. So I think that is possible, but it's your actions are going to be on the master side versus the Minion side. So, all right. Well, we have just a few minutes left, and I want to get to the important part. So the last piece components that I want to talk about on Salt that kind of go into this automation engine is what we call the reactor system. So if we go back to fully automation, this event-driven idea, so I have all these things. I have grains to target and configure. I have pillar where I'm storing data secrets or configuration information. I've got the mine that's storing Minion data to talk upstream and downstream. That really predominantly falls into configuration management. And like I started at the beginning saying, we're not configuration management. What we are is this event-driven real-time automation platform. And what drives that is this what we call the reactor system. So if we go back to the beginning where I said the most important differentiating factor for us is this event bus communication methodology. When I send one of those commands out there, this SALT command here, I send that out there, that's an event. We store that as an event. And then what happens is the minions that are part of that target, they execute that, they take their return data, they make a data dictionary, and they send that back across the wire. And we store that as an event. Well, the beautiful thing is we're built by listening to events. So what we realized we could do is we can say, well, if we're listening for a particular event and we know what that event is, we can react to that event. So if I send a state file out there and that application fails to install and it comes back, you're gonna get the data, I'm like, oh, Mark, you forgot to put in this prerequisite. I know what that is. I get that periodically because I'm dense and I forget that. I'm human, I forget these things, but I know what that is. I know how to fix it, right? We have that in our daily jobs. At least I hope I'm not the only one. But if we know what that event is, guess what we can do? We can go out and fix it. So we get the failure coming in, the event comes in, we're like, oh, we had a failure. Oh, but we know what that is. Go fix that. After it's fixed, go rerun the initial job. All automatically. Meanwhile, you guys have just finished watching, binge watching Stranger Things 2, and it's late and you're asleep, it's 2 in the morning, all that breaks, and you're still sleeping, recovering from your binge watching of Stranger Things 2. And it all happens automatically. And so the reactor system, I get really, really excited about this because this is what differentiates us from everybody else. Nobody else can do this. Even better than that, into our agents, we have built in sensors that we call beacons. But we built in this, we have all these sensors out there in the network, and they're sensing for things like file system changes, processor usage, disk space. They're sensing these things on the agent, and if a threshold is met, we can send an event and react to that event in real time. And we can fix that. So if you have a file system that's filling up with a temp directory, you can get, and I'm getting excited about temp directories. That's pretty crazy. My brain's like, what are you doing? But I love this stuff. But you can react to this file system filling up, and you can go and you can remove that temp directory. There are actions that happen in your environments every day that you can automate that you're now probably a manual process. And then we go beyond that. Oh, and by the way, the fact that this is a persistent, always-on connection allows us to do that. If you used a solution we have a solution called Salt SSH. It's an agentless solution, and what we do, very similar to Ansible. In fact, they're pretty much identical. What we do is we open up an SSH connection, send the commands and run that, and then we close that connection. Well, in that environment, you don't have this persistent always-on connection. You don't have this real-time ability of the sensor to tell the master that something's going on and then to react to that. Above and beyond that, we can react to system events outside the system through API. You can have another system send an event to Salt and react. In addition to that, Salt supports the ability to communicate with network devices or IoT devices. And now this is a real automation platform. We're not talking about just automating continuous integration and continuous deployment and app deployment, which is pretty much config management pieces. We're talking about automating full-on infrastructures. You talk about bringing up a new infrastructure. There's more to bringing up a new application infrastructure than the 5 machines that make that infrastructure. You may need to go talk to a switch and open up a VLAN and create that VLAN. You may need to open up ports of the firewall, or maybe a brand new firewall that you need to be able to configure, or a brand new ESX host in your vSphere environment, and it has certain configurations that you need to deploy. Well, and these devices can't run our agent, but with Salt, we have a thing called a proxy minion that can talk to those devices and configure those devices, put those devices into state, all in an automated. And it's all based on this event-based infrastructure and it's all based on the genius of Tom and what he wanted to create with Salt, leveraging this event bus. So the one thing that I want you to get out of this is grains, pillar, and particularly the mine. Most people don't know about the mine when they're first starting out with Salt. Those are going to be awesome in your configuration management play to target, to configure. But I also want you to get that Salt is much, much more than configuration management. That we truly can drive automation through in your entire infrastructure, not just your nodes, your bare metal or VMs or containers, but your network devices, your edge devices that are out there that you need to log into. Password rotation, for example, you can go rotate the passwords. We have a proxy minion for Nexus switches that one of our customers had, and they had thousands of switches, and every 90 days they had to, or maybe hundreds, I'm probably exaggerating a little bit, I'm excited, but they had hundreds of switches because they have tens of thousands of nodes. They'd have to log into each one and rotate the password. Well, now we can go to that and we can rotate that password with a single state file, put the switch into state with a new password that's stored in Pillar, and all you got to do is change it in Pillar and run the state, and it'll change all these hundreds of switches all at the same time. And really, that is the power of Salt. And that's what I want you to get as you're getting new to Salt. I think you all have your own projects that you're working on. Most of them probably revolve around configuration management and orchestration. Salt is much bigger than that. If you have configuration management plays like Chef, Puppet, utilize that technology. Use that stuff that you've got investment into and orchestrate it with Salt. And then as you build new systems, put Salt into play. Salt is kind of the glue that can mix all these things together. So that's pretty much what I wanted to show you. Are there any questions that I can answer? We're about, I think, if you're in the jacket and then in the back.
So you were saying that installing managed like edge, how does that actually work? Is there
It's a great question. The question is, I mentioned that we can do these network devices and stuff. We have what's called a proxy minion, which is a process that runs in a Salt environment. It's based on Python. And that process translates Salt vernacular to whatever vernacular that device talks. So our Nexus proxy minion talks iOS, right? There's also a Python module called Napalm that supports several vendors. So we have a Napalm proxy minion that'll talk to Juniper or the new Cisco stuff, a bunch of them. And so that's how we do that. We don't actually put anything on that box. We actually do a translation and then talk to that box. In the back? Right there, with you in the green shirt.
So this kind of touches on the beginning part of Salt. How do you recommend somebody who's new to Salt start learning more about Salt, all these different things? Is it books? Is it online training?
So there's a couple. There's a getting started guide on our website. That's a good starting point. I highly, highly recommend that you attend one of our admin. This word's going to scare you away, but trust me. We have an Admin 1 training that goes way deep into several of these components, and that's what I recommend to my customers. Take Admin 1. We offer it every month. It's a week long. It's 4 hours a day. You can take it remotely, or you can fly into Utah if you want. We actually run the actual session in Utah, but most people take it remotely. That's the number one step. There are a couple books out there that have been written by Salt developers, but the best thing that I recommend is getting into one of our training classes. We have Admin 1, Admin 2, and Admin 1 is super deep. So, all right. Well, we're at the bottom of the hour. I believe that's the time we have. But thank you for coming. If you have questions, please feel free to come up and ask. And have a great SaltConf. Please enjoy yourselves. And then come to the party if you want one of these awesome magical T-shirts. There's another cool T-shirt too, but this is my favorite. So, all right. Thank you.